Out of 50, our next question is 20th question. So, Thevenin's theorem. So, basically, according to JNTU syllabus, we have three theorems for first year, second semester. One is a Thevenin's theorem, another one is a Norton's theorem, another one is superposition theorem. For a JNTU, there is no any other option. So, out of these three theorems, one theorem you will get in your external exam, no doubt at all. But in your textbook and maybe your faculty members giving more points for a knowledge base, but this is only for exam point of view only. So here entire answer is modified and simplified a very easy manner here. Even though the statement also in a 2 lines I have given, it's very simple statement I have given here. Okay, totally here I have given 3 circuits and 2 conditions and 3 formulas. So totally for Thevenin's theorem and Norton's theorem, here I have given only 3 circuits, 3 formulas, 2 conditions. Majorly in Thevenin's theorem, we are calculating V Thevenin, R Thevenin, IL. So these 3 formulas I have given. How we are taking or how we are calculating V Thevenin, what is that formula and conditions, and circuit diagram, modified circuit diagram. And R Thevenin, what is the conditions and what is the modified circuit diagram and formula. And same IL, modified circuit diagram and formula. That's it. A simple manner I have given. So you have to remember and study this one as well as possible. It's very easy. What is the statement? First we are going for statement. Voltage source in series with Thevenins and load resistance. So for this statement I have drawn this circuit diagram. It's mean voltage source in series Thevenin resistance and as well as load resistance. This is the statement simply. It's mean you have to write it for any bilateral network or any complex network. We are converting into a single source voltage. That single source voltage in series with Thevenin resistance and as well as load resistance. It's a very big statement is there, but I have modified in a simple manner. Voltage source in series with Thevenin resistance and load resistance. That's it. And you have to draw this diagram for that. And first we will go for calculation of V Thevenin. Here I have given 2 conditions only. The first condition is load resistance in open circuit condition and find out equivalent resistance. Okay, by using circuit reduction technique. So based on these 2 conditions, I have redrawn this diagram, major diagram like this. Okay, so what is the condition? Load resistance in open circuit condition. So here load resistance in open circuit condition I have taken, and remaining all the resistances are there in the circuit, and this is a source voltage. For this one, what is the formula? V Thevenin equal to V into R2 by R1 plus R2 volts. It's mean where we done a open circuit, from that place this resistance is completely useless. It's mean there is no any flow of current through this R3 resistance. Because of that we are taking these 2 resistances only. So according to this formula, opposite resistance by total resistance. So what is the opposite resistance of this voltage source? R2 by total resistance R1 and R2. This R3 is completely useless. It means there is no any flow of current through this R3 resistance because of this load resistance in open circuit condition. Okay, that's why this circuit only applicable. Okay, so that's why here I have written V Thevenin equal to V into R2 by R1 plus R2. Again voltage source here we have, and R2 resistance and R1 resistance you have to substitute. If any case you will get a problem from these three theorems, you will write it. If maybe sometimes you don't have an idea on how to calculate that problem, so by using Thevenin's theorem, just you have to redraw the circuit diagram based on the conditions. So load resistance you have to keep in open circuit and redraw that problem circuit, and you have to write it formula at least, and you have to substitute all the values in that formula: source voltage and R2 resistance, R1 resistance and R2 resistance, and then you will get an answer. It's mean you will learn this Thevenin theorem. This one is useful for both problem, solve the problem, and as well as you will write the long answer also. And this Thevenin's theorem is useful for three major questions. The first question is you will get a short answer Thevenin's theorem statement, or otherwise you will get a long answer for entire Thevenin's theorem, and you will get a problem on Thevenin's theorem. Okay, so that's why you will learn completely these three theorems: Thevenin's theorem, Norton's theorem, and as well as superposition theorem. Then you will get mostly 10 marks, at least 7 marks, minimum 5 to 7 marks. You will get these three theorems you will learn. Okay, you remember. So this is our calculation of V Thevenin. Then we will go for R Thevenin. You remember here again I have given three conditions for calculation of R Thevenin. First, load resistance in open circuit condition. I have done open circuit condition load resistance. Again I have redrawn that circuit. So load resistance in open circuit. In that case also, I mean V Thevenin calculation also, load resistance in open circuit only. Okay, and the second condition, if any voltage sources you are getting in your circuit, that voltage sources you have to keep in short circuit condition. That's why source voltage I have keep in short circuit formation. And if any current sources given in that question, in the sense that current sources you have to do a open circuit condition. So in our circuit there is no any current sources, that's why there is no any open circuit. At load resistance only we have done open circuit, and by using this circuit we can calculate a total equivalent resistance. For that we have one formula, that R Thevenin equal to R1 into R2 by R1 plus R2 plus R3. So we can take this Thevenin resistance in a sense where we done a short circuit. So from that point of view only we can do a circuit reduction technique. So it means we can apply circuit reduction technique. Basically here open circuit in the sense there is no any flow of current through this resistance. Is it right? So that's why we can start from here. So already I have done short circuit at source voltage. So from this source voltage we can take it take the resistance value. These two resistances are in parallel. So that's why I have taken R1 into R2 resistance by R1 plus R2. So already we know that how we can take series resistance and parallel resistance. If you don't know that one, in essence I will do that video also, that okay, no problem and no issue in that. So you have to remember R1 and R2, these two are parallel, that's why I have taken R1 into R2 by R1 plus R2, and this R3 is in series with these two parallel resistances. That's why I have put series resistance plus R3. That's it, simply. This is a simple R Thevenin calculation. Just two conditions only you have to remember always, and this modified circuit and formula. That's it. Then we will go for finally load current calculation. So according to load current calculation, whatever you done calculation previously, Thevenin voltage and R Thevenin resistance. So according to statement you have to draw this circuit diagram, V Thevenin and R Thevenin and in series load resistance. So previously in Thevenin and Thevenin, these load resistance we have done open circuit, but here that load resistance also we are mentioning in series with this Thevenin resistance and Thevenin voltage, and this loop current only a load current. That load current we can calculate by using this formula IL equal to V Thevenin by R Thevenin plus RL. How we can remember? According to Ohm's law, what is the formula? I is equal to V by R. That's it. So that one only we can write it here. But V we have only one V, that one is a V Thevenin, but resistance we have two resistance. That's why I have added those two resistances simply R Thevenin plus RL. Blindly you have to remember this formula. According to Ohm's law, I is equal to V by R. V by R in the sense V Thevenin by R Thevenin plus RL. That's it.